Okay, so we're extending the time work we did last week by now moving on to compound measures. And there are different types of compound measures, but the one that we need to focus on for this year is speed. And a compound measure is one that uses more than one quantity. So where you have a situation where the units are things like miles per gallon would be a compound, population per square kilometre, miles per hour, kilometres per hour, metres per second. Those are all compound units, compound measures. We're focusing on speed. Usually that's measured in miles per hour, or quite often in our metric world in kilometres per hour. And that's the one that we're focusing on. So when we come to work with questions to do with speed, it's really, really important that you're focused on the information they're giving you on the time. Okay? Because by far and away, one of the most common errors I see when I mark any GCSE exam papers that involve time is where you have 4 hours and 15 minutes. If you don't stop and think, you will automatically write that as a decimal like that, 4.15, which is completely wrong. Because when you stop and think, you know from many, many years of telling the time that another way of saying 15 minutes is I'll see you in a quarter of an hour. So 15 minutes is the same as a quarter of an hour, which is of course as a decimal 0.25. So when you write 4 hours 15 minutes as a decimal value, what you would be putting in your calculator to get that maths right is 4.25. Similarly, 4 hours 30 minutes wouldn't be 4.3, it would be 4.5, because 30 minutes is half an hour. It's all to do with the same as I was talking to you about with when we were working with timetables and so on last week. It's not, time doesn't follow the decimal system, so you can't carry over and borrow tens and hundreds. So when you're working with time, the questions are usually straightforward as soon as you engage your brain that that's what you're working with. Now if you're using a calculator, then the calculator does the work for you. Okay, if you type in 4 hours 15 minutes and press equals, that's it as in time version. But if you click your S to D button, you can see that it turns it there into 4.25 for you. So it's just, you need to be switched on as soon as you come across a context which involves time. You need to be looking and wary of that decimal transformation. Okay, and as I've said there, then pressing the time button again will turn the time to decimal and back again. So you've got that toggle between time, minutes and seconds, hours, minutes and seconds, and fraction of an hour. When we're talking about average speed, okay, so if there's an average speed of a complete journey, then you break up your journeys and work out what the total distance overall is and divide that by the total decimal time of the journey, which you can be remembered as the triangle. I think this is the way you were taught in science, SDT, where you cover up. So if you want to find speed, it's distance over time, so distance divided by time. If you want to find distance, it's speed times time. So it's the same as the trig triangles we use to determine whether it's sine, cos or tan, if you remember that. And if you're not sure which way they go, if you think about the units, when we talk about a measure of speed, it's miles per hour. Well, per means over. So miles per hour is miles divided by time, distance divided by time. And that's all you need to remember. So as far as a revision topic, it's quite quick and straightforward. So let's have a look at some questions here. So this is off paper 2, calculator OK. Many of these questions are paper 2. What is 3 hours 12 minutes in hours? Well, on calculator paper, 3 hours 12 minutes equals 3.2. Okay, so toggle in between. As long as you correctly typed it in using your time button, the calculator does the work for you. The first 40 miles of a journey took 1 hour and 15 minutes. The remaining 80 miles were completed in 2 hours 15 minutes. Calculate the average speed in miles per hour of the 120 mile journey. So average speed would be the distance divided by the time. Well, the distance they're telling me is a 120 mile journey. The time is 1 hour 15 and 2 hour 15. So that's going to be 3 hours and 30 minutes, which is 3.5 hours, which is 3.5. So I'm going to do 120 divided by 3.5 equals 34.3 miles per hour. Okay, it's not asking you for a particular degree of accuracy, so you could have rounded out to 34 miles an hour and that would have been fine. So let me just show you how to have done that using your time button. You could have done that as 120 over, and then you could have done open bracket 1 hour 15 minutes plus 2 hours 15 minutes. Because they were just 15 minutes, it was easy enough just to work out what that total time was in your head. The crucial thing is that you put it as 0.5 and not 0.3. Okay, but there, I'm just showing you there. You can just type it in using the time button. It's a really, really excellent button to know about on the calculator. Okay, next one. Glenda plans to drive from Flint to Cardiff. On a long journey, her average speed is usually 42 miles per hour. Last time she drove from Flint to Cardiff, it took her 3.5 hours. Use this information to calculate the distance between Flint and Cardiff. So speed is distance over time. I want to find the distance, so it's speed times time. So distance would be the speed times the time taken. The speed is 42 and the time is 3.5, which I'm going to write as 3.5. So the distance is going to be 42 times 3.5, which is 147 miles. Give a possible reason why your answer in A is only an estimate of the distance between Flint and Cardiff. Well, it's only an estimate because we were only using an average speed to start with. We were only using her average speed. This time she could be taking a different route. Okay, so that distance is only relative to the distance, the route that she took last time. This time she may decide to go up the motorways rather than up through the middle of Wales or something like that. So that's what they're looking for you to say there. Okay, another paper 2. The plan for the flight is shown below. So this has been snipped off another question that that is to do with a flight. So the flight's going from Milford Haven to Rwabon with an average speed of 90 miles an hour, which is going to take 1 hour 20 minutes. And Rwabon to Swansea, which is an average speed of 80 miles an hour, and it's going to take 1 hour 15 minutes. Calculate the total distance of the flight. So if we work out the distance Milford to Rwabon, we know that speed is distance is speed times time. So the speed is 90, and then we've got to multiply that by 1 hour 20 minutes. So that's not 1.2. So on our calculator, 1 hour 20 minutes equals, so that's in time. We hit it again, it's going to give us a distance of 120 miles. So Milford to Rwabon is 120 miles. Then distance from Rwabon to Swansea will be 80 times 1 hour 15 minutes. One hour 15. Remember, with time you have to hit it after the minutes as well. So then if we change that, we get 100 miles. So the total distance will be 120 plus 100, which is 220 miles. Next one, numeracy, paper 2, calculator OK. Gwenda enjoys road running. She keeps a record of a run each day this week. So on Sunday, she ran a distance of 4.6 kilometers, which took her 26 minutes, and so on. Last week, her average speed for the week was 9.6 miles per hour. Calculate Gwenda's percentage improvement in her average speed from last week to this week. You must show all your working. Well, let's ignore the percentage improvement first of all. The first thing we need to do is, in order to compare her speeds in the 2 weeks, I need to work out her average speed this week, and it's in hours, kilometers per hour. So so for this week, total distance is going to be, so you add these up, 4.6 plus 5.4 plus 2.2 plus 6.2 plus 7.2 plus 2.2 plus 3.4, so 31.2 kilometers. Total time equals, so I've got 0 hours 26 minutes plus 0 hours 31 minutes plus 0 hours 12 minutes plus 0 hours 35 minutes plus 0 hours 40 minutes plus 0 hours 14 minutes plus 0 hours 22 minutes equals 3 hours. So the average time, average speed, distance over time, 31.2 divided by 3 10.4 kmh. So that's our average speed. So now I want the percentage improvement. So this takes us back now to work we were doing back in end of January when we were looking at percentage change. Percentage change is the amount of the change divided by the original, what it was, times 100. So the amount of change is 10.4 minus 9.6. 10.4 this week, 9.6 last week. So that's equal to 0.8 divided by what it was. So last week it was 9.6 times 100. Okay, so that's end of January. Percentage change is the quantity of the change. Sometimes it's an increase, sometimes it's a decrease. Over the original, what was it? Well, last week it was 9.6 times 100. So we put that in as a fraction, 0.8 on top, 9.6 on the bottom, times 100 equals 8.3%. So it's an 8.3% improvement. And there was space up there for that. Okay, next question. The travel graph below represents part of Dewi's journey as he walked to a swimming pool, which was 3 kilometers from his home. Okay, so the horizontal axis in the distance time graph is the time, and the vertical one is always the distance. And it's telling us here that this is the distance from Dewi's home. So when it's 0 there, it means he's at home. The graph shows that Dewi left his home at 9 a.m. and walked 2 kilometers to his friend Gareth's house. So Gareth is there. At what time did Dewi arrive at Gareth's house? So he arrived at Gareth's house there, so we need to now figure out the scale of this axis here. And I can see that it's going up in 10-minute intervals at each of those darker squares. If it's 9 to 9:20, halfway between is 9:10. So if that's 9:20, that's going to be 9:30. So that's that. Gareth was not ready, and so Dewi had to wait for him for 15 minutes. Draw this on the travel graph below. So for those 50 minutes, Dewi isn't moving. So the distance from home isn't going to change. So it's going to be a flat line on the distance time graph. And that's what that's how you represent not changing distance, is you'll have a flat line. Where you've got a steep line, the steeper the line, the faster the person is traveling over that distance. So if that was less steep, then he'd be traveling less quickly. So 50 minutes from here, 10, 20, 30, 40, 50, takes me to that point. So that's part B. Dewi and Gareth then walked the final kilometre at a steady speed and arrived at the swimming pool at 10:40 a.m. Draw the final stage of Dewi's journey on the graph above and find the speed at which Dewi and Gareth walked the final kilometre. Give your answer in kilometres per hour. So he arrived at 10:40, which means they get there at that point. And then we want to know what that speed is for that final hour. Now let's answer that first of all. So the speed is the distance. This is part C. Distance over time. The distance is 1 kilometre. And the time is 10 minutes. So that's 0 hours, 10 minutes. got to put it in hours because the question asked you for the speed in miles per hour. So on our calculator, we got 1 over 0 hours 10 minutes. So that is going to be 6 miles per hour. So they walk pretty quickly. Now, if that question had asked, and it hasn't, but if it asked for what's the average speed over the entire journey, then it would be 3 divided by 1 hour and 40, because it would bring that speed down. If we do that, 3. Total distance is 3. Total time taken would be 1 hour 40 minutes. So that would be a speed of 1.8 miles an hour, which is much shorter. If the question had asked what would be the average speed while they were moving, then that would be a bit trickier. It would still be 3 on top because they've covered the 3 kilometers, not miles per hour, sorry, kilometers per hour. So the 3 would still be on top, but this time then you'd have your 10, 20, 30, 40, 50 minutes. They were actually moving for 50 minutes. 10, 20, 30, 40, 50. So that would then be over no hours and 50 minutes. So then that would be 3.6 miles an hour. So it's important to read the question and understand when you're working with average speed what they're exactly asking you to do. Okay, so those are my examples. What I want you to do now, as usual, is to have a go at the questions on the Google Slides. I've put a distance time graph on the slides, but it's one where I'm not asking you to draw on the graph. It's one you're just reading information off the graph. More often than not, on an exam paper, it will be a partly drawn graph where you would have to do a bit more work on that. And we'll practice some of those when we get back to school, so I can actually give you things to write on. Okay, so good luck with that work. Let me know if you have any issues.